This is a video of sine and cosine graphs part 2. So warm up part 1 here. It says find the equation of the sine or cosine function in degree mode that connects the stars. The starting point is at 0, 2. So 0, 2 is right here. So if I go to 0, 2, then I'd be starting on the center line. So that's a sine curve. And the amplitude goes from 2 to 5, which would be 3. So 3 sine. And since my period is 10, 360 divided by 10 would be 36. And then my center line is at 2. And if I hit launch here, the marbles collect the stars there. Next, warm up part 2. Find the sine or cosine function that connects the stars. The starting point is at 0, 6. So 2, 4, 6 right there. The period is 8. So you would end right here. This is going to be a cosine curve. And the amplitude is 4. And the period would be 8, so 360 divided by 8 is 45. And then my center line is at 2. And then if I launch here, so find the sine or cosine equation that connects the given points. The starting point is at 0, -3. Remember to find the amplitude, period, and midpoint, then plug into the form. So here we're starting at 0, -3, ending at 8, -3. So my period is 8. This would be a sine curve, starts on the center line and ends on the center line. My amplitude goes from -3 to 1, which is 4. So 4 sine, and then 36, or 360 divided by 8 is 45. And my center line is -3. I made the same mistake on every slide here. This should say this equation once here, but find the sine or cosine equation in degree mode that connects the given points. The starting point is at 0, -2. Remember to find these 3 things and then plug them in. So we're starting at 0, -2, ending at 12, -2. Starting in the max, ending in the max. It's a cosine curve. The amplitude from -5 to -2 would be 3. And 360 divided by 12 is 30. And then -2. Oops. -5. Sorry. There we go. The center line is at -5 there. Problem 3, same directions. Starting at 0, 5, ending at 10, 5. So my period is 10. Here I'm going down first to a minimum. This is a sine curve. Starts at the center line, ends at the center line. So it's negative. My amplitude 5 to 9 is 4. So sine. And And then 10 into 360 is 36. And then my center line is 5. Problem 4, same directions. Starting on the center line, ending on the center line. That's a sine curve. From -2 to 5, the amplitude would be 7. And then 360 divided by 12 is 30. And my center line is -2. Problem 5 starts at a max, ends on a max. That's a cosine curve. The amplitude goes from -10 to 40, which would be 50. The cosine curve. 360 divided by 60 is 6. And then my center line is -10. Problem 6 starts at a minimum, ends on a minimum. That's a negative cosine. And my amplitude, -30 to -10, be 20. And 360 divided by 90 is 4. And then my center line is -30. So if we add in phase shift, we found equations on the previous slide by using this form of the equation. Adding in phase shift to the equation would give us the ability to write any sine or cosine curve in an infinite amount of ways, depending on our starting point. When we add in the phase shift, writing the equation looks like this. So the only difference here is you're going to, in this parentheses, you're going to have x minus the x value of the starting point. So on problem 10, this is in problem 1, we find the equation that pass through the points and starting at 0, 3 to be 4 sine 45x minus 3. Find the sine or cosine that connects the points when we start at 2, 1. So if we start at 2, 1, then that's going to be a cosine curve. We're starting at maximum, we'd end at a maximum. So, and the amplitude is from -3. So 4 cosine. The period is the same. So everything is going to be the same, except the phase shift. My starting point, my x value of the starting point is 2. So x minus 2 in parentheses, and my center line is still -3. So notice everything is the same here, except for this becomes cosine now, and inside the parentheses is my phase shift, x minus 2. So in problem 2, we found the equation to pass through the points starting at 0, -2 would be 3 cosine 30x minus 5. In degree mode, find the sine or cosine equation that connects the points when starting at this point, 3, -5. So here we're at the center line and going down first. So it's going to be a negative sign. So the amplitude is going to be the same. So we're going to change this to a sine. The period is the same. And the center line is the same, but our phase shift is different here. So we're going to do x minus the x value of the starting point is 3. And my center line is the same. Given the form of the equation y equal a sine b times the quantity x minus c plus d, match the letters with the terms and the transformation. So I don't want to do that. I want to get a, b, c, and d at the top here. All right, so A is the amplitude. What does the amplitude do to the curve? It causes a vertical stretch or shrink, and that's a dilation with respect to the x-axis. So those four cards go together. My B value is equal to 360 divided by the period. So my B value is going to cause a horizontal stretch or shrink. That's right here. And then cause a dilation with respect to the y-axis. And then C is my phase shift. It's the x value of the starting point. And then this causes translation right or left. And then finally D is my midline. And it causes translation up or down.